So let's move on to the next problem, which is this one. Okay, so what is the question? Yes, so for an LTA system, the linear constant coefficient differential equation is given by this one. We have to find out the frequency response of the system. So how do you find frequency response here? We take the Fourier transform and then get the relation between y of j omega and x of j omega. That fellow will give you the frequency response. So how do you solve this? Taking CTFT. Okay, so taking CTFT, let's say this is equation 1. Okay, so taking CTFT of 1, so what will happen? You get j omega whole square y of j omega plus 6j omega y of j omega plus 8 y of j omega would be equal to 2x of j omega. Okay, which properties we have used? Differentiation in time domain property and linearity. Okay, so this implies y of j omega divided by x of j omega. So this should be equal to how much? 2 divided by j omega whole square plus 6j omega plus 8. So that would be the frequency response of the system. Y of j omega by x of j omega is nothing but our h of j omega. Okay, so in that way we can directly find the frequency response of the system. Next question is find the impulse response of the system. Okay, so how are the frequency response and impulse response related? If you take the inverse Fourier transform of h of j omega, you get back the impulse response. So to find the inverse Fourier transform, first we have to factor the denominator of h of j omega. So h of j omega is given by 2 whole divided by j omega whole square plus 6j omega plus 8. So how do we factor this here? So we can write this as j omega plus 2 multiplied with j omega plus 4. So we can factorize the denominator in this fashion, which you can easily verify. Okay, so this, let us apply the partial fraction expansion. So 2 is common, let us keep it out. Now next what we do, we will apply j omega equal to minus 2. So you will get, if you apply j omega to be minus 2, you will get 1 by 2 as the scaling factor divided by j omega plus 2. Similarly, if you apply j omega equal to minus 4, so you will get minus 1 by 2 divided by j omega plus 4. So this is the partial fraction expansion, but this 2 and 1 by 2 will get cancelled out. So finally this is equal to how much? 1 divided by j omega plus 2 minus 1 by j omega plus 4. Okay, so that is our h of j omega. So this implies the impulse response h of t would be equal to how much? Inverse Fourier transform. Which signal will have 1 by 2 plus j omega? E power minus 2t u of t, minus which signal will have 1 by 4 plus j omega as the Fourier transform? E power minus 4t u of t. So that would be the impulse response of the LTI system. Okay, so in that way, from frequency response we can get the impulse response of the system. Next question is find the output of the system if the input is x of t equal to e power minus 2t. So multiple ways to do, but let us do directly in time domain. So what is the question? We have to find out y of t. Because it is an LTA system, y of t is nothing but x of t convolved with h of t. Correct. So this should be equal to x of t is how much? E power minus 2t u of t, and this fellow is convolved with e power minus 2t u of t minus e power minus 4t u of t. Okay, so that would be the overall impulse, overall output of the system. So that should be equal to how much here? So we use the distributive property. You get e power minus 2t u of t convolved with e power minus 2t u of t minus e power minus 2t u of t convolved with e power minus 4t u of t. So this should be equal to how much here? E power minus 2t u of t convolved with e power minus 2t u of t. Something should strike. What is that? E power, this is looking like what? E power minus 8 u of t convolved with itself. So what should be the answer? T times e power minus 2t u of t. Okay. So that we have seen when we talked about convolution property, right? So e power minus at u of t convolved with e power minus bt u of t. When a equal to b, you get this answer. So next result, here a is not equal to b. So what is the answer? E power minus at minus e power minus bt divided by b minus a. So which is 4 minus 2, and this fellow is multiplied with u of t. Okay, so that would be the final output. So let us simplify this. So this should be t e power minus 2t u of t minus 1 by 2 e power minus 2t u of t plus 1 by 2 e power minus 4t u of t. Okay, so this finally should be equal to how do we write? Okay, so I will write this as e power minus 2t multiplied with t minus half plus 1 by 2 e power minus 4t whole multiplied with u of t. Okay, so that would be the output of the system. Okay, so for the given input x of t.